What we're doing is upping the ante by accelerating the rates of natural processes by 100,000, 10,000 times. So we're probably, to that extent, mimicking phenomena that have happened in nature, but at this incredibly accelerated timescale.
In 2006, southern England sweltered under record-breaking July temperatures. It might have been the first flush of a Jurassic climate returning to the Jurassic coast. Meanwhile, carbon dioxide levels continue to rise, heading for twice pre-industrial levels by the middle of the century. Around the world, the signs of change are making themselves apparent. No one knows at what point we might cross a threshold that switches us into real climate trouble. The guesstimate the world is banking on is that we can escape catastrophic change if we can stop CO2 concentrations from more than doubling. But this assumes there are no surprise amplifying effects waiting in the wings. And it's clear from warming signals in the Arctic, change can be unexpectedly rapid.
Much of Greenland has changed rather dramatically, much more dramatically than any of us would have thought 10 years ago. The icebergs you see behind me are all from Jakobshavn Isbrae, Greenland's largest outlet glacier. In about 2000, the glacier began speeding up and is now flowing at about twice the rate it was in the mid-90s, which means it's now putting out something like 50 to 60 cubic kilometers of ice a year, which is going to have an obvious impact on sea level rise.
It's this sudden loss of polar ice, both from the land and particularly from the sea, that has the potential to amplify warming and nudge us more swiftly into a hothouse future. As temperatures rise, there is less shiny white ice left to reflect heat away, and more dark Arctic Ocean ready to absorb it. The faster the sea warms, of course, the quicker the remaining ice melts. It's the sort of feedback loop that could help flip the switch on ocean circulation, and perhaps set the stage for the next major phase of ocean stagnation. Already, scientists report signs that the Gulf Stream has begun to weaken, and in late 2004, part of the current actually shut down for 10 days.
We would like to be able to conclude that these types of consequences are just buried in the distant geological past, but in fact, at least the early stages of widespread oceanic anoxia is where we're probably heading with fossil fuel burning. In terms of the concern that humans should have for the alteration of the environment that supports us, it's certainly on the time scale of concern.
As the human population climbs towards 7 billion and the desire for first world affluence spreads across the globe, we're burning oil as fast as we can pull it out of the ground.
Cars and suburbs and roads and that whole model of sprawl, which is based on sort of the bounty of oil, is starting to spread to China and India, where they're actually on this frenzy of road building. You know, so Shanghai, for example, they don't allow bicycles anymore in Shanghai, in the city. When the Chinese people start driving cars the way we do, then we'll have long passed the tipping point for you know, for climate change.
The thirst for crude is pushing civilization simultaneously towards two perilous futures. In one, the flood of cheap energy we've taken for granted will dry up faster than we can adapt. In the other, our headlong rush to use the last of the resource could plunge us into an unpredictable climate catastrophe. On the face of it, you might expect that running out of this stuff will at least save us from the climate threat.
The latest work of the climate scientists on this subject, the Intergovernmental Panel on Climate Change, says that we can afford, I use that word in inverted commas, if you make certain assumptions about the amplifying factors, the feedbacks in the system, we can afford to put into the atmosphere another 400 billion tonnes of carbon. Well, you just look at what's left in fossil fuel reserves below ground. You've got 700 plus in oil alone, if you count the regular oil, and just a bit of the easily accessible unconventional oil like the Athabasca tar sands. Then you've got 500 billion in gas and coal. Forget it. It's 3,500 billion and counting. So we can cook our planet many times over if those assumptions are right.
Jeremy Leggett spent much of his early oil industry career at the prestigious Royal School of Mines in London, training others in the fine art of finding oil. The threat posed by climate change prompted him to switch camps, first to Greenpeace, and more recently to lead a UK company providing solar alternatives.
My abiding fear is that I'll live through what remains of my vocational life in an exciting, fast-growing company while the world is going to hell in a bucket because of the stupid addiction to oil that we've had all these years and the effect it will ultimately have on our economies after the peak of production and the collapse in supply, plus, of course, the unfolding effects of global warming, which just get worse by the month.
Pumped from its hiding place beneath the Arabian desert, our carbon atom is once more playing its part in the great drama of life on Earth. Meanwhile, the second half of the Earth's endowment of crude lies underground, waiting for the human race to suck it up. Somewhere ahead, one way or another, the end of the oil age is coming.
Our whole civilization has evolved in an era of stable climate, which is probably anomalous in terms of, if you look at it over geological time. So was this our moment in the sun, which is now coming to a close? That's sort of a pessimistic view, but I think perhaps could be true.
Really and truly, you've got to be a flat earther not to see what's going on now and what's being projected by all the scientists studying climate. If we keep going as we are, we will wreck our economies and wreck our planet and really completely decimate ecosystems.
Well, I claim that our grandchildren are going to look at us and say, you burned all that oil, all those nice molecules, you just burned it? And we'll have to admit we just burned it.
Oil is a precious thing. Fossilized sunlight captured by tiny, brainless organisms that lived for a mere instant in geological time. Yet every year we burn more and more of what we have less and less of. Are we mining the aftermath of past climate catastrophes simply to engineer our own? It would be ironic indeed if the end of our oil age becomes the start